Okay, we are ready to start notes on section 2C for the Math 4 course. And yes, your math test will be radical. That is what we're playing with today is radical functions, square root functions, and particularly how they relate to piecewise functions. We'll also continue to dabble in word problems with piecewise functions. So let's get straight into number one. Graph this guy below. We'll start with the top part. X minus 4, well, that's y equals mx plus b. That means we're going to start at negative 4 on the y-axis, and we're going to go up with a slope of 1, 1x minus 4. Slope of 1 means up 1 over 1, up 1 over 1, up 1 over 1. And we'll go to the point where x is 4. And we're going to stay on the lower side of 4x is less than or equal to. Means we'll put a nice big dot there and then draw our line back down this way. And so that will be the first half of our graph. Now the second half, square root of x minus 2, and the minus 2 is not inside the parentheses. So this is an up and down thing. Now normally for a square root of x, we'd start here and we'd say up 1 over 1, up 2 over 4, kind of like what we would do with the parabolas. And we draw a sideways parabola like that. Well, that's fine and dandy, except for this is square root of x minus 2. So we're going to drop down 2 units, and then we're going to play the game up 1 over 1, up 2 over 4. Oh, look, we're right there. Now, when we go back and we look at what kind of limitations we have when x is greater than 4, that means that where x is 4, we're going to have an open circle there. And if that line were to have continued here, it would go on in that direction. Something like that, vaguely like that. And so we don't need the lower stuff, but we'll keep the upper stuff. Now, we need to address, is this a continuous function? Now, I think last time we picked up on 2 ways of doing it. We can look at it graphically, and the fact that there is a solid circle inside the open circle means that this is continuous, at least at that point. We can also look at what is happening at the 4s. What is happening at the 4s? Well, didn't mean to lose that. All right. So what is happening at the 4s? When I stick a 4 in there, 4 minus 4 equals 0. When I stick a 4 in here, the square root of 4 is 2. 2 minus that 2 is 0. And so since they match where x is 4, y turns out to be 0 in both senses, yes, this is continuous. Now, having said all of that, I'm going to kind of pause for a second and comment on things that I have been finding in textbooks and such, because I've been looking at this, because I almost want to say that last year when I taught continuous function in Math 3, I want to say that I had a slightly different take on it. And the more that I researched it, the more I found out that there really is more than one take on how to define continuous. Perhaps the most rigid definition says that you must have a line that goes from negative infinity on the x to the positive infinity on the x with no breaks like this. Now, this particular graph that we were staring at in front of us would fit that definition. But if we were to have somebody that did say this, start here and go that way, there are some that would argue that this is not continuous because it doesn't go forever in both directions. So I'm going to warn you that, as you go up the ladder, you've got me for Math 4. Whether you take, something like pre-calc or AP Stats next year, or if you're a senior, you go on to college and you have a professor, they may have a slightly different definition of continuous than I do, so just be aware of that. But I will say this, when I am asking you if this, is this graph continuous or not, I am talking about this guy right here, where they connect or don't connect, as the case may be. And I think I mentioned this one other time, just to say that they have a domain of all real numbers does not make it continuous. Because if I had a graph that did this, like that, the domain would be all real numbers from negative to positive infinity. You would have no lapses in the domain, but you can't call it continuous because there's that gap there. So just understand that there is a slight difference between the two. All right. So let's move on. Example 2. We've done this sort of thing before. This time we've got what appears to be a square root curve involved. Now I want to talk for a second about this open circle down here. Because, if this had been like this, then we would have looked at the blue dot and said, okay, closed circle for the blue line, and the red line must be an open circle. We've done that before. But now we're staring at this. Wait a minute, the blue is the open circle. Does that mean that the red is the closed dot? No. Otherwise, you would have had a red dot there. So the fact that we have a blue open circle actually tells us that more likely than not, both of these are open circles. So that's what we're dealing with in this kind of situation. So let's start with our function notation. F of x equals big bracket, and then we're going to do the blue line first. The blue line, it's a straight line, so the first thing I'm going to be after is the slope. And usually I will like to pick on those points where the line crosses the horizontal and the vertical, all three at the same time, because that way I can figure out this is my slope. Rise 2, run 1, rise over run, right? So I know that my equation for the blue guy is going to start out with 2x, because that's my slope. Now all I got to do is figure out, all right, up 2 over 1 gives me here, up 2 over 1 there, up 2 over 1 here. I need to know that it crosses at 4, because that is the y-intercept of the equation. Now, we never quite make it up that far because we stop here at the open circle. That open circle is at -2. So we're going to say for all x's below -2, that this equation works. And now we really don't need this stuff anymore. Now we can focus on the red guy. The red guy does appear to be a square root curve, like a sideways parabola. And so if this is, it almost looks like the vertex. If I were to go up 1 over 1, good. If I were to go up 2 over 4, good. That tells me that this is, kind of like a parent y equals square root of x. The only issue is that it is 2 units to the left. And so we have to write it accordingly, square root of x. And remember, when we're up underneath the umbrella with the x caught up in the parentheses with it, we always do the opposite. So, 2 to the left sounds like -2. This would be +2. And this would be for all x's that are above -2. We discussed that earlier, that we're presuming that this is an open circle because nobody is filled in at that point. So they both got to be open. All right, that should handle that. All they did was ask us to write the equation, and we did. All right, this guy gets back into a bit of review on topics that were covered in Math 3, and that is playing with square root equations. In this particular case, they want you to solve it for d, or to put it differently, they want you to get d by itself. That, to me, that, if I can rephrase it that way, that helps me focus on what I've got to do. I've got to move the 356 away, and I've got to get the d out from underneath the square root bar. Now, I'll say this, this whole idea of rearranging an equation, why don't we just fill it in with what we got the way it is? and solve it that way. And the response is that in the real world, in the workplace, there are many occasions where you are using the same equation over and over and over again. And, in the next problem they give us the speed, which is S. And that means that we're having to move everything away from D every single time we solve this equation. Well, why not just do it once, get D by itself, and then use that over and over again? And this is what happens, especially in the sciences. Lord knows there's a formula for everything in the sciences. You want to be a nurse? There are formulas out the wazoo that help you calculate if a person has a certain body weight, how much of the drug, how many cc's or how many milligrams do they need of this particular drug? It's usually based on their body weight. And so they have these formulas that are already rearranged in the right order so that all you got to do is plug in their weight and you can figure out how many milligrams that they're going to need. And that's because somebody did just what we're doing here. They rearranged it the way we needed it ahead of time. So we're going to divide by 356. And so we're going to have this guy on the left, and we're going to have square root of D on the right. And so what we'll do in order to get D out from underneath it, it's going to take squaring. We're going to have to put a parenthesis around this and square everybody. So we're going to have S squared. And if memory serves me correctly, I'm doing this strictly from memory, but I'm pretty sure that the number was really, really close to that. I will fire up my calculator just because we're going to need it in a second. That is correct. Okay, the old memory is still alive and kicking for the most part. All right, so part 2 says we're going to take this formula and say, what if the speed of the tidal wave is 115 kilometers per hour? What is the average depth of water? And notice that they say that D is the average depth of water in kilometers. Your science teacher will thank me for stressing to pay attention to the units here. Because sometimes you'll have, speed in kilometers per hour and, you'll have your depth in meters. That's not the same kind of unit. So here actually, it's kilometers per hour, and the depth in kilometers is actually relatively similar. So we're going to plug in the 115 where the S was and square that and divide it by 126,736. And when we come out the other side, it is about 0.10435. Well, the 104.3 tells us that the 4, we're not going to round it up. It's going to stay where it is. And that's kilometers. And I will put a dot there because that means approximately. That means we just rounded our answer. It's not an exact answer. And I look at it this way, 0.104 kilometers doesn't sound like a whole lot until you realize that there are 1,000 meters in a kilometer, and 1/10 of that would be 100 meters. Now you're talking about a tidal wave that is 100 meters high. Now, a close approximation for 100 meters is 100 yards, which is the length of a football field. Can you imagine a tidal wave the size of a football field coming at you? Yeah, I would say a quick prayer because that's all you got. So that is how we plug that in. We rearrange it to find D by itself, plug in what we need, and the rest is calculator work. All right, now, this one, I would consider this an exercise in test taking 101. First of all, I will notice that there's these dotted red lines down the middle, which usually when I see something like that, I think of an asymptote. That imaginary line where a graph will get closer and closer and closer to it, but never quite touch it. Well, you'll notice that in answers B, C, and D, there's a solid dot that is touching the red dotted line. What is up with that? So this is obviously not supposed to be an asymptote. Now, the other thing I would point out is that the red dotted line is not in the same spot. If you'll take a good hard look at this, you'll notice that for A, the red dotted line is where x is -1. For B, it's where x is +1. For C, it's right on the y-axis. And for D, it's x equals +1. So, the only thing I think that the red dotted line has in common with these drawings is that it just shows you where the two batons are being handed off from one graph to the next, so to speak. And in one case, we have two open circles. In the other three, we have an open and a closed circle. Well, you look at your equations that you have to work with, you're going to have an open, you're going to have a closed. That much you know. So already we have figured out that this guy is no good because he's got to have a closed circle somewhere to fit with the equations at the top. Now, looking at 2x and looking at x squared minus 1, I think I would rather play with the 2x. That looks like it would be easier to play with rather than playing with the x squared minus 1, playing with a parabola. Dotted line, straight lines, you can do slope. Well, the slope of this would be 2. Now, I'm also going to notice that there is no y-intercept, so technically speaking, this is 2x plus 0. So I'm looking at where this line will pass through the origin. Here it does it here. There's not even a straight line in this one. We can rule that one out. Again, this is test taking 101. So when you can rule out some of the options, it improves your chances, and it also helps focus, on the answers that do count. Now, this guy over here, if I were to stretch this line out, he would cross down there. But now I got to ask the question, does the straight line go up forever or does it go down forever? Look at that. X is less than 1, which means that I'm going to be doing this guy right here, which means that this guy right here doesn't even count. Well, I've just ruled out 3 of the possibilities. Now, as it turns out, this parabola, just to show you why this makes sense, we're looking at that dotted line, that red dotted line, and we have to remember that that is not the axis. The axis is actually here. X squared minus 1 means that my vertex should be dropped down 1 notch on the y-axis. So my parabola is actually doing something like that. So that makes sense. That, if I'm starting there, over 1, up 1, there it is. Over 2, up 4, there it is. Over 3, up 8, it's going to be right there. So, this thing is following the pattern beautifully. So long as we remember where, figure out where the starting place is. So that is why this one is the correct answer. And there were a couple of things that we could look at just to rule out the other ones before we even got to the x squared minus 1. All right, this one is a bit of a trick question. Name a whole number, and it's actually been so long that I have played with the whole idea of whole numbers and rational numbers and that sort of thing. I had to go back and refresh my memory that they're really talking about integers here. So, 0, -1, -2, and so on. That would count. Now, which whole number is not a part of the range of the piecewise function? And a lot of folks have a tendency to look at this left to right, and they'll see the -4, -6, and they'll see the -8 here, and they'll say, oh, anything below -8 should count. And you forgot something. Range. Range talks about the y's, not the x's. So that would mean that literally -1 would count, -2 would count, -3, -4. In that direction. So yeah, -10 would have fit if you had given that as the answer. But, for somebody that asked this on a test is likely to name the first whole number that is not a part of the range. And that would have been -1. All right, identify the domain. This, I have about decided that this little beast right here, when you stick a negative with the x inside the square root like that. For some reason, it negates the rule about do the opposite. You would think that you would flip it on the y-axis so that instead of doing this, it's doing that. You would flip it on the y-axis. And then this would say, now move it 2 to the left. That's the way we would normally interpret it. But for some reason, when you're inside the square root like that, it does the opposite of the opposite. It actually comes over here. Whoops. If this is 2, then it's going to do that. And that is one of those, I'll be honest with you, I don't quite understand why it's backwards of backwards like that, but it's one of those questions I intend to ask God when I get there one day. But, and if you really wanted to chase this, you could do everything from 2 all the way down to -2 and discover that there's an answer for all of these. When I stick a 2 in there, -2 plus 2 is 0. Square root of 0 is 0. When I stick a 1 in there, -1 plus 2, that's square root of 1, which is 1. And, the further that you go down, you will eventually find, that it may not be a pretty number, but it is a real number, because if you stick a 3 in there, you go out here to where 3 is, -3 plus 2, that creates square root of -1. You can't do square root of -1. That's the imaginary number. So just be aware of that when you have a negative x inside the square root like that, your usual rule for what you're going to do with the number with x actually does the opposite of the opposite. And that is the end of the notes for 2C.